Uh, so in the continue of the part two, actually, so in this part, I will make how can you design the half header using the NOR gate. So the circuitry I already explained. So I am designing here the half header using the NOR gate. Okay, NOR is the also the NOR gate is also the I mean universal logic gate. Okay, how can you design? So this expression I already explained you that as per sum that is the A XOR B. Okay, this stands for the A XOR B. How can you write this expression? A complement B plus A into B bar. If you design half header using NAND gate, na, something is easy, but using a NOR gate it will be little bit I mean the difficult. Okay, how? So this expression you can also write like that AB plus A bar into B bar. I hope you understand this thing. Complete bar. This is nothing but the expression of exclusive NOR gate. Okay. So this is the exclusive NOR gate. AB plus A bar into B bar. If you place the complement, overall complement, then we'll get the XOR gate. Okay. So this is nothing but the expression of the XNOR gate. If you take the complement of the XNOR gate, we'll get the XOR gate. So this way I can design we can design the half header using the minimum number of NOR gate. Here I will discuss the minimum number of NOR gate. This is our concern. Minimum number of the NOR gate. Okay. See here. So firstly, I will make the AND gate. In the earlier part, I hope you already watched the previous video. I explained if you want to make the AND gate, we will need the three NOR gate. Okay, NOR gate symbol is like that. So this is the NOR gate, and this is the expression A plus B whole bar. And so how can we design this circuit? I'm erasing this thing. You know already the logical symbol of the NOR gate. Okay. See, firstly I will design this end and COT you know already. COT expression is A and B. No issue. Okay. So AB, how can we design AB? See, this is the A, this is the B, and finally will get the AB. How? See, this is the A, this is the B bar, and if you paste A bar plus B bar the whole bar, ultimately with the help of the De Morgan law, that is the AB. Okay. Now, just how can you design A bar into B bar? Okay. See, just place here one NOR gate. So by the help of the De Morgan law, here at the output we will get A plus B whole bar means A bar into B bar. Okay. And finally connect with them with one NOR gate. So this is the so finally here we will get the AB plus A bar into B bar ka whole bar. If you break, so this expression is equivalent to A XOR B. I hope you understand. Okay, so this is the A XOR B. So this is the sum expression. And if you ask from me, sir, so you didn't consider. I mean, you didn't consider COT. So the my answer is I have already considered this thing. Okay, COT is AB na. So this is your AB. So this is your COT. Okay. So this way you can design the half header using the NOR gate and how much. So here what are the minimum number of NOR gate? Only 5. So one thumb rule I am telling, if you design the half header using NOR gate or NAND gate, how many, the minimum number of NAND or NOR is required? Only 5. This is your thumb rule. NAND is also 5 and NOR is also 5. Okay, I hope you understand this thing. And one famous, one famous interview question also I will discuss. How can you design the OR gate with the help of only the half header? How can you design this thing? If you want to think like that about, so I mean, don't, I'm, I mean, give you the time yourself, okay, and try to think how can you design the OR gate. A plus B, that is the OR gate. How can you design the OR gate with the help of, so if you want to write like that, then okay, I will write it. Design of OR logic gate, OR gate using half header. How can you design? This is the very famous interview questions. Okay. How can you design this thing? Okay. So the process is simple. Just you need to break one expressions. So I mean, what are the importance of the breaking this expression? I will explain in the. So we'll get the answer automatically. Okay. Just I am giving one expression to you, and and try to break this thing. Expression is A XOR B XOR AB. So I hope you already, I mean the get qualified student. I mean, so recently, so meanwhile you are doing the MTech or BTech. So definitely you must have an idea of the Boolean algebra. So with the help of the Boolean algebra, you can break these expressions. So don't see this video. Right now, and just try yourself. And if you want to break this expression, so what output you will get? Just try yourself and then watch this video. So watch from this. Okay. Uh, I hope you try already. So, so if you try already, then definitely, the sum of friend will get the A plus B. Okay, and sum of friend might be there is possibility. The don't get A plus B. Okay, so this is the A plus B. How can we break? Okay, see here. So A XOR B XOR. Okay, just I am assuming AB is X. Just assume this is the X. So firstly I will break A XOR B. Okay, firstly I will break A XOR B. How much it will get? That is the A bar B plus A into B bar. Okay, so this is the expression of XOR get. XOR X. AB I assume X. X is equal to AB. Just I assume this thing. Okay. So A XOR B, A complement B plus AB complement XOR X. How can you draw after that? So this is also, so this is the so you can consider this is the input one and this is the input two, and this is the symbol of the XOR operation. So A bar B plus A into B bar, or make overall complement into X plus X bar into A bar B plus A into B bar. Okay. So you already know about the De Morgan law. So can you break this thing with the help of the De Morgan law? Okay. So A bar into B complete bar into, dot. If you apply the De Morgan law, plus will convert in the dot operation. Dot A into B whole bar. Okay. This is the X plus X. Otherwise, you can place with the help of the X is AB. So this is the AB and X bar. So X is AB. So if you break this thing, so AB whole bar with the help of AB whole bar with the help of the default contour, you can write A bar plus B bar. So A bar plus B bar. A bar into B plus A into B bar. Okay. So just here you need to just this is the application of the numerical law only, nothing but. So here A plus B bar, A bar plus B, A bar and complement meaning is same. Okay, and this is AB plus. So if you multiply this thing A bar into A bar, one thumb rule I am telling. If you multiply A bar into A bar into A bar, something like that, means A complement up to n times, it will always equal to the A bar. Okay, complement and meaning. So this way you can also write the A bar into A bar into A bar. This is the symbolic. You can put bar, yeah, right, the complement. Okay. So the multiplication, no issue. If you multiply A into A up to n times, the result is A. Okay, no issue. This or the meaning is same. So this way, here I will put A bar into A bar. So the meaning is same. Means if you multiply this thing, this is A bar into B. And A bar, so here I am multiplying this A, the complement this thing. To complement, complete this equation. So this is the same A bar into B, A bar into A. Yeah, if you ask from me A bar into A, it will give the 0. This is the law. So this is the Boolean algebra law. Okay. So A bar into, so this expression will get the 0 if you multiply this and this, will get 0. A bar into A, no issue. B bar, if you multiply complete with 0, overall 0. Okay, this also B bar into B, that is 0, plus B bar is same. So A into B bar. I hope you are understanding this thing. Okay, and just multiply this thing also. A into A bar, so that is the 0. A into A bar 0, A into A bar 0 plus AB plus B bar into A bar, B bar into A bar, or plus B bar into B is the 0. And AB is the multiplication. Okay, plus here how much we will get? A bar into B plus A bar into B plus A into B bar. Okay, so just you multiply with the help of the AB, that is the AB. Okay, and if you multiply this thing completely 0, AB into because B bar is there now, yeah, A bar is there, this is 0. So plus so you can write this expression A bar into B plus A into B bar. I hope you are understanding. So if you ask from me, sir, we need to break this expression at the time of interview. No, if interviewer will ask, then you can break. Just uh, uh, just I mean patience. You have so here I'm breaking this thing. So how much we will get? AB plus A bar into B plus A into B bar. Okay. In the next slide, I am writing here. How much we will get? After breaking this expression, AB plus A bar into B. So this is this is nothing but it is the application of the Boolean algebra. If you have an idea of now, you can break any expression. I can understand that some student will face the difficulty to break the Boolean expression. Okay, no issue. So if you take here the common B, if you take the common B, so A plus A bar. Okay, and in the Boolean algebra, so there is a law. If you add if A plus A, yeah, A dot A dot, if n times is there, the result is only A. So if you want to use any The variable two times you can use for the minimization purpose. So here AB I am using the two times. Two times you can use, no issue. This is the law of the Boolean algebra. So AB plus AB you can write two way. Multiple times you can write. How much time you need it? You can write. Okay, this is the law of the Boolean algebra. So here I took the common B A plus A bar plus here I will take the common B bar with the same AB. So here how much you will get? No, no, not B bar. Sorry. A I will take the common. This is the AB bar and AB. So here take the AB, B plus B bar. Nothing but here I wrote AB two times. You can write, the one variable multiple times. How much time you needed? This is the law of the Boolean algebra. Okay. So in this, I took the common A bar. If, sorry, here I took the common in this two variable B. If you take the common B, A plus A bar. Okay. So this result you will get the B plus uh, this one, this one and this one. I took common here A. So A B plus B bar. So there is the A. So finally we'll get the expression of A plus B. So if you break this expression, na, A XOR B XOR AB, I mean it takes actually I'm breaking this thing continue from 5 to 6 minutes. Okay. So if you break this way, A XOR B XOR AB, you will get the A plus B. So this is the OR gate. So this is the OR gate. Okay, so how can you design the circuit? So this is the expression. So this is the output of the half header. This is the sum. You know already A XOR B. And AB just stand for the carry, C out. So just I will here I am placing the block diagram. Okay. So this is the input, two input A and B. Okay. And this is the So this is the carry and this is the first sum. So this is the sum and carry. You know already. And this sum and carry will be input of the second half order. So actually to design the one OR gate we will need the two half header. So here I will place one more half header. Okay. Okay. And see here. So C out expression is AB and this is the A XOR B. So this is the half header 1 and this is the half header 2. Means the output of first half header will go the input of second half header. Okay. And finally, this expression how XOR symbol is stand for the sum. So this is for carry and this is for the sum. So finally, just I am writing. If you write here S, yeah, yeah, you can give the any name. Just I am giving the Y. Okay. So please sum of this half header. Yeah, you can write here the sum, no problem. Sum will give the XOR expressions. Okay. So here the one input is A XOR B, A XOR B, and one input is AB. XOR AB. So if you break this thing, we'll get the A plus B. So how many half header is needed? Two half header. So if you want to design the one OR gate using half header, how many half header is needed? Two half header. So if you ask from me, sir, we need to break these expressions. So I think no need. If interviewer will ask, then you can break. Otherwise, if anyone asks, can you design the or get using half header? Yeah. So just place the two half header back to back, and the input of the first half header is the A and B variable, and the output of the second half header is the sum and carry. Means the input of the second half header, the output of the first half header, that is the sum and carry. and after that the the sum of second half order, not carry, the sum of the second half order will get the OR gate finally. So I hope you understand this thing. So I may actually in the two part I didn't cover. So in three part I covered each and everything about the half header. Okay, thank you. In the next video we will meet.